5-3, solving systems of linear equations by elimination. Same standard, 8EE3, and again we can see here now we are on to our last method or skill of solving via elimination using our system of linear equations, finding our one solution. Today, as you look at it, the 4 steps here. First, multiply, if necessary, one or both of the equations so that we have this goal of opposite coefficients so that one of the terms will cancel on out. As you can see here, we talk about adding. Then we're going to solve the resulting equation. And then whatever we get for that answer, whatever our solution is, we're going to sub it back into one of the original equations again. Notice here in our step 2, it does say add. Well, we have talked about usually in our 5-3 lab we've done previous to this lesson about how you could subtract as well, but as in our phrase in my class, we talk about don't subtract, add the opposite. So again, normally we've done a lab before this, so this might be going a little bit faster than you'd like, or maybe you need to see it again, so always feel free to rewind an example, watch it again. Or whether you want this to go slower or faster, you can here on YouTube adjust the speed. Just remember, if you adjust the speed on this video, it adjusts it for all of them, whether you have slowed it down or sped it up. Always an option. Just remember that applies though to any video you watch after this, whether my notes or something you're watching for fun on your own computer, hopefully during free time and not when you should be doing homework. It will always keep that speed until you reset it back to normal, the 1x. Solve by elimination. Again, any subtraction, don't subtract, add the opposite. I'm going to put that down as a -1 to help me remember. We talked about it yesterday. Our whole goal is to put a line underneath here and be able to put a plus sign because we want to look at, do we have opposite coefficients? If we add these, do the x's disappear? Does 3 plus a -3x give us 0? Oh, it does. Perfect. So go ahead and cross them off. Don't put down 0. Cross them off and then continue all the way through, adding everything else. A -1 plus 4 gives us a positive 3y equals, and then again, we're going to add everything on that side. Gives us 30. Solve that equation. Divide by 3. And you get the final answer of y equals 10. Now you take that, just like we've done before, and you plug that back into one of these original equations, whichever one you like better, whichever one you prefer. I'm going to start with the first one again, somewhere wherever you have room, down below, off to the side, in between boxes, wherever it is. Write out that original equation. Yes, on your assignment for me and Mr. Walls' class, please write out this original equation. Why? Because I told you so. That's one reason. But more importantly, so you have it written correctly. So that way, as you're doing the work, you will do the right work with the right problem. Plug that in, whether you want to put a time sign or parentheses, as per usual, the choice is yours. I usually just stick with a time sign, as you'll have seen in class. And then we've got equals 14. Simplify down, so I got 3x. Careful, that's plus a -10 equals 14. From there, solve again by adding the opposite. So I'm going to add a positive 10 because then those guys cancel. I'm left with 3x equals 24. Divide both sides by 3. And you have x equals 8. Done. If you have to, by instructions, by your teacher, by the assessment on a quiz or test, if it says to check your solution, that means when you write down again x first, then your y value in a parentheses, if it says to check it, then that means you need to take and you need to plug both 8 and 10 into both of these original equations to get a truth statement. In this case, 14 equals 14 and 16 equals 16. You could do that quick as a mental check, which I usually do in class and have done in preparation of this, or use a calculator and checked it as well to make sure 8 and 10 do come out. Now, just because I checked it doesn't mean I haven't made a mistake, so let me know. Just like in class, sometimes I make mistakes there too. As previously mentioned on the other side, our goal is to be able to add these together. So if we added them, do they cancel out? Does 3x plus 7x cancel out? No. Does 4 plus 4y cancel out? No. Well, you may have seen it yesterday where you said, well, Mr. Walls, these here have the same coefficient, so why don't we just change this to subtracting? Well, you could do that. The only problem is when we talk about subtraction, you have to remember to subtract all the way through, meaning you have to remember that that's 3x minus 7x to give you a negative 4x. These guys would cancel, but then you have to remember that this actually becomes 6 minus a negative 14, and that's where we make mistakes. Mental math, we forget about that subtraction to get us a positive 8. So that's why a lot of times you're going to see me say don't subtract, add the opposite. We're going to switch to just adding. In order to do that, like we discussed in that lab, if we've done that previously, I'm going to look at this equation just because I picked it because I want to. And I'm going to take that, and because I have a positive 4y up here, I'm going to take and multiply this whole thing. So I usually put brackets to remind myself to multiply the whole thing by negative 1. So then if you want to, you can draw an arrow. You'll see me have done that previously. So then I got a negative 7x plus a negative 4y equals 14. Notice I've distributed that negative 1 to everything. Negative 1 times 7, negative 7, negative 1 times 4. And because I'm multiplying the entire equation, that's why there's a bracket, I need to multiply this over here as well. Once I have done that, you'll see me just like I did in the lab before. If you didn't see that, then here you see it now, where I'm going to rewrite that other original equation. Careful, make sure that that matches the other one. And then now we've met our goal where we can put a little line underneath and add them together, where we get negative 4x. These guys cancel because that one was negative, equals 8. Notice we did get to the same answer, whether you subtracted them or multiplied one by a negative 1. There's just so many rooms for mistake. That's why you saw in our instructions that we're not going to subtract. We're going to make sure we can add things. Either way, when you're done with that, divide by negative 4. So that gives you x equals negative 2. And just as before, we're going to take this value and pick one of them. I'm just going to go with that first equation and plug it into that example there. Find some room. I have some down here to the side. So I'm going to rewrite that equation. 3x plus 4y equals negative 6. Sub on in. 3. The x value we just found was a negative 2 times it or parentheses, whatever you so prefer. Just showing you again a little different way to write it. So that, careful, is a negative 6 plus 4y equals negative 6. Solve by adding 6 to get rid of these guys and get rid of these guys. Oh, that's interesting. 4y equals 0. That's fine. Solve for y by dividing by 4. When you've done that, remember that y then is going to equal 0 divided by 4 just gives us 0. So you're done. If you've circled them up, please remember I do not accept that. Your final answer needs to be an ordered pair where it has to be the x value first. So 0 or negative 2. Which one was with the x? The negative 2. Then the 0. Put parentheses around it. In my class, the parentheses are a point. Don't forget. And then there's your answer. Wherever you have it, box it up to help it make it easier for you to find it on your homework or assignment, on a quiz or a test. It's optional. It does help me find your answer a little bit quicker. Again, we're doing this because we're going to solve systems, however they're written, with 2 variables. Today we're using the elimination and finding our one solution that we have. Another system, don't subtract, add the opposite. Our whole goal is to be able to add them together. When we add them, the x's don't disappear. They don't cancel. They don't become 0. When you add the y's, careful, that doesn't get you to 0, so that's not going to work. This is where we're going to have to pick either x or y. The choice is yours. In class, we'll have a greater discussion about this, but you pick one of those, x or y, and you're going to eliminate them in these equations. I'm going to pick y because one of the coefficients, one of the numbers in front of y is already positive and one is negative. Now we're going to have to multiply the top equation by a number and the bottom equation, the second equation, by a different number to find this LCM, the least common multiple, a number that we can take 4 and 3 and multiply them up to. So when we talk about that LCM between 4 and 3 is going to be 12. Looking at that then, I want to get this -4 to become -12. 4 times what gives me 12? 3. I did that because now when we distribute that all the way through, we get 9x plus a -12y equals, don't put 33. That happens sometimes if you need to. That's why I tell you, draw those loops so it reminds you. Please, since it's your notes, draw the loops to all of those. Now again, we did that because now we look down here. 3y times what? 3 times what's going to give us 12? Put a 4 there and then distribute it. Because now we get 16x plus a positive 12y. This is the whole goal, was right here. Now we have opposite coefficients. Positive 12y, one negative 12y. Equals not 19. Be very careful. Draw the line since it's your notes. It's going to give you 76. Draw that line. Now we're here where we can add them together. That gives us 25x. These guys cancel, so just cross them off. Equals 175. If you're going to do mental math, be very careful. I did mental math wrong on this when I was preparing for it, for this video. X equals 7. Watch that because that's where I made my mistake. Now that we know that x equals 7, go back to one of the original equations, the choice is yours, and plug it in. The first equation or the second equation, whichever one you find easier, for whatever reason, I'm going to pick the second one so you can see that. Again, with me in Mr. Walls' class, when you do that, rewrite that original equation. Yes, you can probably jump a step, but I want you to rewrite that so you've got the correct one. Again, making sure this matches that second equation because that's the one I picked. Don't make any mistakes or errors. Then you're going to plug in our value, 7, because it says it's x. I'm going to plug that in for my x value. So 4 times 7 plus 3y equals 19. Now we solve that equation. So we got 28 plus 3y equals 19. Add on both sides that -28. Yes, you could subtract, but for mental math purposes, that's why I do it this way, where I get 3y equals, again, don't lose it, that's a -28 there, because that's going to give me a -9. And dividing them both by 3, y equals a -3. Put them together, the x value first, so make sure between the -3 and the 7, you know which one was for the x. It'll say x equaled, so that's your cue there. -3, put them in parentheses, box them up. If your teacher assignment or quiz or test says to check it, please make sure that you do check that. This one looks a little bit different. We're going to still use the same thing with elimination. We're talking about the equal sign, so as I mentioned before, I'm going to rewrite this right away so it's a little bit helpful to us to see it. 5x plus 5y equals 15. It's the same thing, Mr. Walls, I know, but line up those equal signs. Now it's a little easier to see that when we try to put that line underneath, whoop, and just add them, if we add them together, do the x's cancel here? Nope. If we add them together here, do the y's cancel here? Nope. Oh, look, there's an x on the other side. Don't panic. If you add the equations, do the x's disappear? Nope. So we're going to focus on the x or the y because the y's are here on the same side of the equation. That's why I rewrote it, because then after rewriting it, with those equal signs lined up, it makes it a lot easier to pair up our like terms on the same side of the equation. So I'm going to pick those y's because they're on the same side. I'm going to eliminate them. Since I have a positive 5y up here, I'm going to change this guy into a negative 5y, which means I have to multiply the entire equation, so I'll put a bracket around it, by negative 5. If you have room to continue writing sideways, you can do that. It's very helpful, or however you're going to do it. I need to go down to the new line where I'm going to have this now. Negative 5y equals 10x, a positive 10x, because when you distribute two negatives, it makes a positive, negative 15. There's that second equation that I've rewritten after distributing. So I'm going to write that first equation again. I'm going to keep everything lined up, the 5y, the equal sign, and then I'm going to put that 15 way over here because it's already lined up with its like terms. Again, we did that because our goal is to be able to add. Yes, you can subtract if that's what your teacher wants to do. I'm going to show you the adding because that's the steps we have. We did that because these guys cancel. We're left with 5x on the left side equals, here's the 10x, and then, well, those guys cancel. That's all right. So we solve this equation. Variables on both sides. Interesting. Well, all you're going to do is just pick one side. I'm going to pick this here. I'm going to add a negative 5x to this side, add a negative 5x to this side, because I want them both on the same side. So this leaves me with 0, interesting, equals 5x. That's fine. And then from here, we're just going to continue on, and we're going to divide both sides by 5. 0 divided by 5 still gives us our answer of 0. Now that we know x is 0, choose one of those equations again from the top. Plug it on in. I'm just going to pick that one we can see there. It's the second equation because I find it the simplest or the least amount of work involved with it. Copy it over correctly, then plug it on in. Y equals negative 2 times 0 plus 3. That cancels out. So we're told that y equals 3. So again, we get that ordered pair, x value first, followed by y. Put it in parentheses, and you've got your answer. Mental check allowed. Or, again, you can do the check all that work if your teacher or assessment or work requires it. There are 340 calories in 2 cups of cereal and 1 cup of milk. There are 570 calories in 3 cups of cereal and 2 cups of milk, right? And solve a system of linear equations, then to find out the number of calories in 1 cup of cereal without milk. Now in class, you guys would have a small discussion. We would have it about calories and milk, and who cares, just look at it. But just take this as an example. So we're looking at this, and each one in its own spot. So first up, we know 340 calories are in 2 cups of cereal with 1 cup of milk. I'm going to call these guys just as I see them. Cups of cereal comes first, so I'm going to call that X. And then cups of milk come next, I'm going to call that Y. I'm going to write that out just as I see it. I'm going to write it differently just so it looks differently for once for you guys. 340 equals 2X, 2 cups of cereal, plus 1 cup of milk, 1Y. Then the next one, we have 570 calories in 3 cups of cereal and 2 cups of milk. So I'm going to write that one out again just as I saw it, keeping things lined up nicely. 507 total calories if there are 3 cups of cereal, so that's 3x, plus 2 cups of milk, that's 2y. We have now successfully written a system of equations. Now up next is to solve it. Since today we're using elimination, I will do just that. We'll need to multiply each equation by a separate number to get to a spot where we can eliminate things, or maybe just one of them if we pick it that way. So I'm going to pick this first equation, and I'm going to multiply it by a negative 2, because then that gives me a negative 680 equals a negative 4x plus a negative 2y. And I did that because then when I write in this next equation, 570 equals 3x plus 2y. I can then put my line underneath of it, put a plus sign, and these y's, because they have opposite coefficients, will cancel. We're left with a negative 110 equals Negative 1x, we don't want that negative 1, so get rid of it by dividing both sides. So 110 equals x. Wonderful. Solve the system, so let's plug it in for one of those other ones for the y value. So again, I'm just going to look right here. Now I'm going to plug it into that equation that I can see nicely as I'm right down here. I'm going to rewrite it because that's what we're supposed to do. So I'm going to rewrite it. You find room. You need to go in between the lines. You can below the box. Bleed on to the next one. You can do that. So again, 570 equals 3x equals 3x, so that's times 110 plus 2y. I'll rewrite this so we can see it nicely here. Otherwise, there is that way in class I talk about how you could show this step of work and move on quickly here. Subtract by 330, or as I usually do, I'll add a negative 330 to both sides for mental math purposes. I'm going to move over here just to the left so I've got room there. So that gives me 240 equals 2y, divide by 2. 120 equals y. Great. So now a lot of times we're going to come over here and you're going to want to just say 110 and 120. And you want to box it up, woo, and say final answer. But remember, when we go back to that equation, go back to this, it said to write and solve a system of equations to find the number of calories in 1 cup of cereal without milk, or with 0 cups of milk. So what we're actually looking for is an equation that looks something kind of like this. 1 cup of cereal, 1x, plus 0 cups of milk. We want to know what that equals. So plug it on in. 1 times our x value, 110. Well, Mr. Walls, that's just 110. Yep, you're right. Plus 0. We don't have to do that, Mr. Walls. You're right, but on the chance it said 3 cups of cereal and 4 cups of milk or anything else, you just plug it on in and tell me what we get. That cancels out. We're left with 110. So that means to answer the question, there are 110 calories in 1 cup of cereal and 0 cups of milk. We did this because this is allowing us to solve system of a linear equation, and today we're solving it by elimination, seeing our one solution, and we're able to write systems of linear equations as well. That's our goal, to write and to solve systems of linear equation using our method of elimination, and as well, whether we like the milk problem or not. Example, we have other real life problems we can do as well.